Let's talk here just a few minutes about titration. Titration is a lab procedure where you take, well, we're going to do acid-base titrations here, where you take an acid or a base of an unknown concentration, C, probably molarity, and you take your, let's say you have an acid, A here, of an unknown concentration. You'd take a measured volume of it, and you would add a base of a known concentration until you reach what's called the end point. Now, how you know you've reached the end point? A couple of ways. We did it both ways in lab. In one, we knew we had a strong acid and a strong base, hydrochloric acid and sodium hydroxide. So the salt that was going to be produced would be a neutral salt. So we used a color changing indicator. In fact, we used two different ones. We used phenolphthalein and bromethymol blue, and we looked for a pH of 7. When the pH was 7, we knew that we had equal amounts of moles of the acid and of the base. So we were able to use this formula here, the concentration of the base times the volume, the number of milliliters of the base that were added, would equal the volume of the acid, how many milliliters of that were put in, times the unknown concentration of that acid. Now, another way that you can do it, if you don't know what pH to expect, you can do an electrolytic titration, like we did, where we used a pH meter and we gradually, slowly added. In the case of what we did, we started with an acid that had a low pH, and as we added the base, the pH crept up, then it suddenly shot up, and then it flattened back out again. Now the equivalence point is in pretty much the center of that vertical part. And again, if we start with a weak acid, this won't be extremely low. And then the equivalence point would go over here. We'd look at pH, and it would be higher than 7. Then the volume of the base that we added would be down here on the x-axis. So we get our volume from here, add our equivalence point, and plug it into this. So let's say that we had an acid of an unknown concentration, and we used 10 milliliters of that acid, and our base we knew to be 0.2 molar, and let's say it took 20 milliliters of that base to reach the end point. Now again, the end point is either indicated by the second derivative of this graph. Some of you will get that, the inflection point here. Or we may have used a color changing indicator. The one we used to give us a pH of 7 turned green right at a pH of 7. So all we do here is that this C times 10 equals 0.2 times 20, which is 4, and we divide by 10 on each side, and we get that our concentration is 4/10 or 0.4. Okay. Like I said, there's a good bit more to it than that, but we're down to just the last minute here, and I just wanted to review the most basic and important parts about titrations and titration curves. Now remember, with a weak acid being titrated by a strong base, you'll get something that looks kind of like this. This won't start out real low, like down around 1. It'll be, weak acid, it'll be up 2, 3, 4, and this will end up fairly high, and this equivalence point will not be at 7 over here. It will be higher than 7. If we start out strong acid and we titrate it with a weak base, it'll start out lower. It will not go up as high. That'll shift the equivalence point down to something lower than 7, because the strong acid will win out over the weak base, and at the equivalence point we'll have a pH lower than 7. Okay, so that is all I have for you right now about titrations. I hope all these things help.